An absolute value inequality is a little bit different than solving an absolute value equation. And so you're going to want to make sure that you write down this table into your notes. If you look, solving an absolute value equation is right here. Okay, because if you remember, we talked about if you solve the absolute value of the absolute value of x equals 8, we know that that means that x equals 8, or x is going to equal a negative 8, because absolute value means distance from 0. Okay, the absolute value of 8 is 8, the absolute value of negative 8 is 8. Okay, so that's this part right here, that's solving equations. But let's talk about all this other stuff. When we talk about inequalities, we got to think about what we mean. So let's say we wanted to know what the absolute value of what number is less than 8. Okay, well, what that would mean, okay, if you just think about it, this means the distance from 0. So the distance from 0 has to be less than 8. Think of a number line. If we're talking about the distance from 0 is less than 8, okay, over here our absolute value would have to be somewhere between 0 and 8. Okay, if we took the absolute value of 7, 7 is less than 8. Okay? But we also have to remember absolute value means negative. So let's look at a negative 8. Okay? We want the absolute value of a negative 8 to be less than 8. Or I'm sorry, the absolute value of some number to be less than 8. Well, negative 6. If I took the absolute value of a negative 6, is that less than 8? Sure, 6 is less than 8. So all these numbers in here, when you take the absolute value, it'll be less than 8. So notice that our solution is going to lie somewhere between negative 8 and positive 8. And that's what these two are talking about right here. So when you take the absolute value of something, and here they have ax plus b, or you can just have ax or just x, is less than c, what that means is we're going to be talking all the values less than 8, for example, right here, and all the values greater than a negative 8. And just kind of stick with me through this. We'll do some examples and I'll show you what I mean. Okay? When we're taking an absolute value inequality, we can't just say it equals 8 or negative 8. We're talking all the values in between negative 8 and 8. Okay? So, when you have an absolute value inequality, if it's less than or equal to, you're going to set up two and statements. Your expression is less than c, and your expression is greater than a negative c. That's right here, okay, because it kind of works opposite our distance from 0. Okay, so when you have a negative, our distance from 0 has to kind of stay in that range. Now, if you look for when it's greater than or equal to, okay, those are or statements. It means greater than or equal to, those are or statements. So for example, let's say here was 0, and we had the absolute value of x is greater than 4. Okay, well, that means the distance from 0 is greater than 4. So if this is 4, our distance from 0 has to be greater than 4. It has to be 5 or 6 or 7 or so on or so whatever. It also means that our absolute value has to be outside of this negative 4. Because if I took the absolute value of a negative 5, would that be greater than 4? Sure it would. Absolute value of 5 is 5. I'm sorry, the absolute value of a negative 5 is 5, and negative 5 is greater than 4. Okay, so we have to talk about kind of all the values on the outside of 4 and negative 4. Okay, so that's what this is, an or statement. Okay, your expression is going to be greater than c, or it's going to be less than a negative c on the outside. Okay, and the same thing goes for greater than or equal to, or greater than or equal to. Your expression is going to be greater than your constant, or it's going to be less than the opposite of your constant. Okay, so again, make sure you have these written down, but let's look at an example. This says solve x plus 6, I'm sorry, the absolute value of x plus 6 is less than 8. So, remember we see absolute value, we know this has to be 8 or negative 8. X plus 6 is going to be something to 8, and x plus 6 is going to be something to negative 8. We should automatically think that when we see absolute value. Now, since we're talking about less than, or think of the number line. Okay, here's my 8. That means it's got to be less than 8. It's got to be between 0 and 8, but it's also got to be between 0 and negative 8. Okay, so when you see that less than sign, think less than, think and statement. Okay, so we know it's got to be less than 8, but we also know it's got to be greater than negative 8. And if that is hard to remember, just remember that when you put a negative here, you got to flip the sign over. Okay, almost kind of the same thing with solving inequalities. When we multiply or divide by a negative, we reverse the inequality symbol, do the same thing. Okay, solve them just like we always did. X is going to be less than 2. Remember, we're doing and statements here. And if we subtract 6 from each side, I apologize for kind of being off here, x is going to be greater than negative 14. Okay, so kind of seems, you try to think of it on a number line. If here is 2, x is going to be less than that, but it's got to be greater than this negative 14 over here. Okay, it's got to be less than 2, greater than negative 14. So remember, we read our compound statement as negative 14 is less than x, which is less than 2. Okay, so our solution is going to lie somewhere in this range. Again, when you see less than, you write your first equation, just whatever the expression is less than your constant, and then you also write the expression, flip the inequality, is greater than a negative 8. Let's look at another example. This one says solve the absolute value of 3x minus 3 plus 4 is greater than or equal to 10, and then we'll worry about graphing it. So let's start with our inequality. Remember, just like solving equations, we want to get rid of whatever's outside the absolute value symbol. So 3x minus 3. Actually, I don't need to rewrite that yet. Let's get rid of our plus 4. And since it's plus 4, we'll go minus 4. Whatever we do to one side, you do the other. And we're left with the absolute value of 3x minus 3 is greater than or equal to 6. Notice we're talking about a greater than symbol. So when you talk about greater than on a number line, we want it to be outside of our 6 and negative 6. And that's kind of how I try to remember it. If it's greater than, okay, we want it to be the numbers outside here. So we know that 3x minus 3 is going to be greater than 6, but we have set up another inequality. 3x minus 3, and it's going to be something to a negative 6. Quick, easy way to remember it. Always the second equation where you make this negative, flip your sign over. Less than or equal to 6. Okay? So we want to be on the outside here. So, solving both of these equations, we add 3 to both sides. We're left with 3x is greater than or equal to 9. Dividing both sides by 3, x is greater than or equal to 3. Our symbol doesn't change here because we divided by a positive. Okay. Looking at this equation, inequality, we add 3 to both sides. We're left with 3x is less than or equal to negative 3. Divide both sides by 3, and we're left with x and a negative 1. Did you multiply or divide by a negative number? Nope, we divided by a positive number, so it stays less than or equal to 1. Okay? So technically we always should write the smaller one first. So we would say x is less than or equal to a -1, or, remember this is a greater than or equal to sign to start. If it's greater than or equal to, we're talking about an or statement. We're talking about it being on the outside on our number line. So x is less than or equal to 1, or x is greater than or equal to 3. Okay? Now it did say to graph the solution. So if we want to graph the solution, x is less than -1, or x is greater than or equal to 3, take your number line, and if we put 0 right here, here's going to be 1, here will be 3. I'm sorry, that's a -1. Okay, so let's first graph x is less than or equal to -1. Circle on -1, since it can be equal to, we fill it in. And we're talking about all the values less than -1. We're also saying x is greater than or equal to 3. So I put a circle on 3, fill it in, and we're talking about all the values greater than 3. What this means, ladies and gentlemen, is that you could stick in -2, -3, negative whatever, and it would make our original equation true. Remember, we said we wanted it on the outside. Okay? Or we could pick a number bigger than 3, 4, 5, whatever, and it would make our original equation true. Okay? So when we have a greater than sign, that's going to be an or statement. It's either going to be less than -1 or greater than greater than 3. When you have a less than sign, whether it's less than or equal to, then we're dealing with an and statement. It's got to satisfy both of them. Okay? So until you get comfortable, really rely on this chart and make sure you're understanding that if it's less than or equal to, it's an and statement. If it's greater than or equal to, it's an or statement.